Hello, good morning, and welcome everybody to IMR's July webinar, Leveraging Artificial Intelligence for the Circular Economy, Strategies and Insights for Irish Industry and the Public Sector. We're just going to leave it about 30 seconds before we get properly started. While we're doing that, you can help me out and you can use the chat function on your screen and let me know where you're watching the webinar from, whether it's which county you're in, which town you're in, which country you're in, whatever you want, where in your house you're watching it from. And I hope nobody here was hit by the major IT outages. Luckily, we're still able to go ahead with the webinar. So it's Vincent from Letterkenny. Welcome, Vincent. Claire watching from AAG H1 Shannon Airport. Claire, I hope Shannon Airport is doing okay after those power outages. I believe airports were hit. Chris in Donegal, Yarns Kilcar, Thomas in Belgium, welcome Thomas. Fergal in RD, hey. Dorothy, EPA, welcome Dorothy. William in Scotland, Frank in Bangor. We are 31 minutes past, thank you for that. Let me know as well if it's your first time joining an IMR webinar or if you're returning for more of the good stuff. Fionn in RD, Farrell Furniture, okay, lots of people answering now. Camilla in Carrick and Shannon. Fergal in Dublin, Jerome, Durnan, Farrell Furniture RD. Okay, welcome everybody. The room is filling up nicely. So I think with that we can get started. So again, for those who have just joined, hello, good morning, and a very warm welcome to IMR's July webinar, Leveraging Artificial Intelligence for the Circular Economy, Strategies and Insights for Irish Industry and the Public Sector. And what a lineup we have for you this morning. First up, we're going to have the wonderful Geraldine Brennan, the head of circular economy here at IMR. And Geraldine is going to be giving us an overview of the EPA-funded AI project, AI for CE, standing for Artificial Intelligence for the Circular Economy. And this project is where the strategies and insights have been developed. So up after Geraldine, we will have IMR's head of AI strategy, Carlos Garcia. If you are a regular attendee to IMR webinars, you'll be very familiar with Carlos, who is no stranger to them. His most recent appearance being in March, as he presented on applications of generative AI in manufacturing, the recording of which can be found on IMR's blog page or YouTube channel. Carlos will be demystifying AI and AI's role in circular economy implementation for us. We will then bring in Enya O'Connell-Hussey, our Circular Economy Project Officer, and she will be introducing us to some industry case studies where companies are implementing AI in their circular economy journey. Valentina Rangel, IMR's Circular Economy Policy Officer, will bring us through some regulatory drivers before Geraldine comes back in to take us home with insights for industry and policymakers. We're also joined by Vina Grace Thomas, our Industrial Research Analyst, and she will be available for the questions and answers at the end, should any of you have questions around the industrial research. If you do have any questions throughout the webinar, please use the Q&A function. You can find it on the bottom of your screen, and we'll get to them at the end. And with that, let's get started. So welcome in, Geraldine. Take it away.
Thank you, Gary. Good morning, everyone. Delighted to be with you all today. Before I give a high-level overview of the objectives of the AI4C project and some of the outcomes and outputs from the project, I just wanted to start with a little bit of context setting in terms of why the circular economy is important, in case anyone has any doubts with regards to the importance of scaling circular economy in Ireland, in the EU, and globally. This image we've got on the screen here is from the Ellen MacArthur Foundation and a Swedish think tank, Material Economics, back from 5 years ago, where they looked at the role of the circular economy in ultimately solving and addressing carbon reduction, and fundamentally highlighting that whilst 55% of our projected emissions by 2050 come from energy use and can be solved by emerging technologies connected to for the likes of carbon capture storage, and also things like diet shift, fundamentally 45% of emissions are locked in the production, logistics, use, and end-of-life management of products and their packaging. And therefore, the circular economy is effectively the missing piece of the puzzle with regards to addressing emissions and negative environmental impacts. So again, the team will go through different elements of circular economy in the context specifically of AI. But before I dived in, I just wanted to paint that picture for anyone perhaps who's new to this conversation around the role of circular economy in climate action. So the project more specifically, as Gary flagged, AI for C stands for artificial intelligence for circular economy, so effectively it as an enabler. The project is just over 2 years in duration. It's an industry-oriented research project funded by the EPA research program. And one of the key characteristics of the project has been the industry-oriented nature and the stakeholder engagement and ecosystem collaboration that comes with doing industry translational research. You'll see below key members of the team, some of which are on the webinar today and some of which could not join us. In terms of some of the key project objectives, one of them was to unpack key barriers, risks, and opportunities associated with using AI adoption to accelerate the deployment of both circular practices and business models. The second key outcome was to develop an industry decision support tool to bring to life, through cross-sectoral case studies, real-life examples, the ways that AI technologies can be deployed to implement circular economy and ultimately address circular economy goals. And then to also develop a best practice and policy guide to demystify circular economy, AI, and the role of AI as an enabler of circular economy for both industry and public sector stakeholders. In terms of the way we've worked, as I mentioned, it's industry-oriented, it's translational, stakeholder engagement with industry and public sector actors interested in both AI and circular economy has been fundamental, but so has been working with the academic sector who are also operating in the space. And the EPA funded 2 projects looking at AI and the circular economy. So IMR and Maynooth, the leads for these 2 projects, AI for C and Circ AI, decided to work together to engage with industry and also to develop joint deliverables, mindful of the fact that there can be a lot of noise in the ecosystem and that we were stronger together. And what you see there are examples of how we work together, be it collaborating in webinars over the course of 2 years and collaborating in each other's stakeholder workshop in order to share insights as we've both gone on this journey to unpack this really important topic. In terms of the decision support tool that IMR has launched as part of the AI for C project, it was launched in April this year. It's a 3-step effectively process. One is an interactive online toolkit, which asks you a range of different questions, defines concepts, which then leads you to a point of giving you tailored case studies based on your interests with regards to both circular economy, your business needs, and what you'd like AI to do for you. It then takes you to a user feedback. Some of the insights from those user feedback surveys I'll share at the end of today's webinar. And then any actor who completes the survey will get a bespoke user report which summarizes the concepts as well as selected case studies of good practice. This tool is available, it's free to use, and a colleague of mine will put a link in the chat. So if you haven't used it before, we really warmly encourage you to do so. And then when it comes to the best practice and policy guide, some of which the insights for today's webinar are coming from this piece of research, it's targeting industry and public sector stakeholders, and it summarizes the status of AI and C adoption in Ireland. It covers the AI and C policy landscape, both at a European level and at an Irish level. It includes guidance for industry considering using AI for circular economy implementation. It also includes selected industry case studies and insights for public sector stakeholders. And this is something we've done leveraging the insights both from the Circ AI project and our own experiences, given the collaborative nature between these 2 EPA-funded projects. Lastly, before handing over to my colleague Carlos, I just wanted to highlight some dissemination highlights we've had over the course of this just over 2-year project, one of which was last year Ireland hosted the Dublin region circular economy hotspot, and the project was featured in the Irish Independent Special Report on Circular Economy. We were able to launch the AI for C toolkit in April at IMR's biannual Industry Members Day in Mullingar. And more recently, my colleagues Enya and Vina Grace delivered a keynote at a seminal practitioner and industry-oriented event, the Manufacturing and Supply Chain Expo in the RDS on the IoT and Industry 4.0 stage. Without further ado, I will now give the reins to Carlos.
Thank you. Thank you, Geraldine. So as Gary said in his presentation, I'm going to talk about artificial intelligence. I will try to demystify the use of AI, and in particular as an enabler, as a support of circular economy. So let me start with a quote from the Irish National AI Strategy, where it says that AI has a great potential in the area of climate. AI applications can be used to monitor, to reduce energy, to provide environmental monitoring, risk management, and to help prevent and mitigate environmental crises, among other things. So this is a pretty broad and general statement, but it signals clearly the importance of AI today. Everyone from small, medium enterprises to multinationals to the government are looking into AI and how it can help. So slowly but surely, we are looking to AI as one, maybe even the most important tool to help us tackle crucially important challenges like the environmental crisis. But this also highlights the need to balance the current hype and expectations that we all have about artificial intelligence with the reality and the real potential that it has, which is substantial. So when we look at artificial intelligence, many times we see definitions of artificial intelligence related to human intelligence, like artificial intelligence is creating machines that think like humans in one way or another. I think this is a mistake because it distracts us from the fact that AI is a broad term. It encompasses various applications of data science, but it's a tool. And we need to look at it as a tool to help us with in manufacturing, how can it improve our efficiency and how can it be an enabler for circular economy. In this regard, I like the definition of AI from the EU AI Act, which does not mention human intelligence at all. So AI, as I said, is a very broad term. It goes from machine learning, which is learning from the data, to deep learning, to natural language processing, to first order logic, to planning, to reasoning. And so there are many techniques in AI, but today we are all talking about generative AI, large language models, the likes of ChatGPT, Claude, etc. And generative AI is a subset of AI to create new content, right? But don't forget, generative AI is just a small part of artificial intelligence, and we have been working researching AI for manufacturing for a long time. So don't get flashed with generative AI. It has its uses, and we are working on that. What are the best uses for generative AI? But AI is much more than that. As with any tool, you need to select it based on your business challenge. That's the important thing to take into account. See if I can move to the next slide. Yes, so looking at the Irish industry a little bit more in detail, we can see that AI is nascent in Irish manufacturing. According to Eurostat 2023, we can see that 7.2 Irish manufacturing firms used AI in 2023, which is not a lot, but still better than the EU average of 6.8. And also we can see that while AI has broad applications, including ICT security, logistics, production processes, customer engagement, marketing, etc., we often see today attempts to use generative AI and large language models for multiple applications, which often fall short of their actual capabilities. And this highlights, again, the need to balance in an artificial intelligence world, the balance ambition with realism. Ensure that AI is applied where it can genuinely add value. Our goal should be to integrate AI thoughtfully and effectively into manufacturing processes to drive real improvements in efficiency and sustainability. And regarding this, we can see that from the IBEC report, digitalization is a top priority now for manufacturing businesses, which is what we see. When we talk to companies, many, even small, medium enterprises are looking more into the data they have, are acquiring data a lot more, and they're asking, okay, what now? What do I do with the data? And in AI, we see multinationals are more likely to use AI than a small, medium enterprise, which is to be expected because they have been working with data over a longer period, and many times they have dedicated data analytics teams. And as I said before, AI is a broad term, but it is essentially a form of data analytics and data science. So the more experience you have working with data with data management, with governance of the data, the better your chances are to effectively apply AI. AI is not a magic wand that you just, look at a problem you have and say, okay, AI is going to solve this for me in 1 week. No, it's not like that. You need a continuous working with the data and working with AI to actually get it to be really efficient for the business case you have. And the last point there is also important. We know manufacturing, we know what are the main worries day by day of manufacturing, right? It's my costs, my sales. So circular economy and sustainability is often, or most of the times, it's not the main priority of manufacturing firms. But there are many examples, and we will see a few later with Enya, where being sustainable also brings efficiency and improvement gains. And this is where we need to start applying AI in manufacturing. So in terms of capabilities, where to apply AI? As I said, AI is nothing new. We have been applying AI in manufacturing for a long time. So what capabilities are common for artificial intelligence? We can look at fault detection and diagnosis, so detecting the faults as soon as they happen. If you are looking at stream of data and maybe being diagnosing why it happened. We use it with robotics and automation. We use it to optimize processes all over the supply chain, to manage the energy consumption, to interpret complex data, which is where, for example, generative AI can be very good to use to look at different or complex data, or if you have many different dashboards and you spend your time looking at 5-7 different dashboards, where generative AI can help there. Forecasting, making predictions, which is a common use of AI since a long time ago, and also sorting and categorizing material, which is very important for circular economy. So looking at the product life cycle and in circular economy, where can we find artificial intelligence uses? Okay, let's start by product design, phase number 1 there. This is, again, a good fit for generative AI. As I said before, generative AI is about creating new content. So it can help creating new designs that a human maybe didn't think about. And those designs, we can make them to be not only more efficient or stronger, but we can also say that those designs should be more sustainable. For example, do a design that is easier to recycle at the end of the life cycle, for example, more sustainable. So that's a perfect use of AI. In stage number 2 there, processing and manufacturing, as I said before, AI is being used in many places, from scheduling to optimizing processes, to fault detection, to predictive maintenance. Then we move into the use, logistics, and distribution, number 3, where, again, scheduling is very important here, the handling of warehouses, for example, optimizing the stocks in the warehouses, how much stock you need. Perfect use for artificial intelligence. And finally, if we move to number 4, collection and segregation, we can, for example, think about using computer vision with AI to look at the waste and try to segregate and say, this is something we can reuse, or this is not, or look at an electronics component and take a decision. Is this something we need to refurbish, or no worries, it's better if you just treat it as waste. So the use of AI is, you can find it in all across the product life cycle. And with this, I will hand it over to my colleague, Enya.
Thank you, Carla. So now that we've explored a little bit about the circular economy and about how AI is applied in manufacturing, let's see what it looks like in practice to use AI to enable circular economy and business goals. So we'll start with a case study from General Motors, who were looking to optimize designs using generative AI. So electric vehicles are a lot of the time heavier than an equivalent internal combustion engine, which means more energy to move. So General Motors were aware of this fact, and they partnered up with a company called Autodesk to use their generative design AI software to create a new design for a component of a seatbelt. So this component, the AI was able to generate a series of designs, and these were optimized based on performance, cost, and material use. And then this design, the selected design, was paired with additive manufacturing, which meant a bit more geometric freedom. And the resulting part that was created by this generative design AI software was 40% lighter and 20% stronger. So they used less material and they got better results. So that's hitting their circular economy goal of using less material inputs, and it's also hitting a business need of a better product and lower costs. In addition, because they used a single component made of a single material, it's a whole lot easier to recycle. So our next case study is from Sundenbelt, which is a Danish infrastructure company. And they were tasked with the maintenance and repair of over 46,000 US bridges. So they wanted to digitize and automate their manual inspection and maintenance processes. So instead of sending a human being up a bridge to take pictures of the bridge and find anywhere that needed faults or any faults that needed repair, they instead partnered up with IBM to use a software called Maximo. And this software uses drones, which collect data. And then this data is sent back to the software, which creates 3D models of the bridges that can detect cracks and rusts and any other defect that needs repair. So the solution created a 30% reduction in the time between an incident being detected and repairs being carried out. And this translated into an estimated increased lifespan of up to 100 years for the bridge. So because the bridges are lasting longer, they estimate that they can save up to 750,000 tons of CO2. So moving on to our third case study, which is to do with food waste in the food sector. So Winnow is a company that created a software for tackling food waste within industrial kitchens. So in a typical commercial kitchen, up to 20% of food is thrown away. So that is a huge source of greenhouse gas emissions. So what Winnow does is it has a software, a very easy to use software that scans food being thrown away. The AI is able to identify what exact food it is, and then a weighing scale generates data, which is fed back to the software. And then the software is able to analyze the data and tell staff where in food waste is occurring. So this allows them to make decisions to be more efficient, to reduce food waste, which is obviously a big cost saver for them. And it also translates into huge savings with CO2 and water. As we can see, up to 78,000 tons of CO2 can be saved a year, and over 404 billion liters of water is saved by using the Winnow software across the various applications. All right, so our final example is to do with retail reverse logistics. So it's from a company called Optoro. So within the UK alone, up to 20% of sales in the retail sector are returned by the consumer. So with online shopping and very liberal return policies, this is an increasing problem. And most of the stuff that we return is not resold. A lot of the times it can end up as waste. So Optoro is a technology company that uses an AI software that uses predictive analytics that can sort the returned products and decide what products are resellable. So it analyzes the data and it decides for the retailer what product should go where. So whether a return should be put back on the consumer market, whether it should be recycled, returned to a vendor, or donated. So it's quite widespread. It's used by companies like IKEA and Best Buy in the US. And in 2016, they partnered up with Groupon. And through a pilot study, they found that the use of the Optoro platform diverted over 100,000 kilos of retail waste from the landfill. In addition, because they're being more logistically efficient, they're saving a huge amount on fuel. So they estimate over 122,000 liters of fuel saved from logistical efficiency alone. So now that you've seen in practice how AI can enable circular economy goals, I'll move over to Valentina, who's going to talk a bit more about how the regulatory and legal considerations around artificial intelligence and the circular economy.
Thank you very much, Enya. So in this section, I will be telling you which are the regulatory drivers for adopting circular economy and what are some of the legal considerations that you should take into account if you're going to be using AI to enable circular economy. So to start, I would like to highlight that circular economy has become a priority at a European and at national environmental policies because of its importance for achieving climate targets and decarbonization, as Geraldine highlighted at the beginning of this webinar. At a European level, we have the Green Deal, that is the European strategy for achieving climate neutrality by 2050, and it is a comprehensive set of initiatives that also highlights the importance of digitalization in this goal. And one of the main initiatives is the new Circular Economy Action Plan. This Circular Economy Action Plan was published in March of 2020, and its main goal is to reduce the consumption footprint and also to make sustainable products the norm. At a national level, we have the Climate Action Plan, which is the roadmap for achieving the national climate targets. And it also put an obligation on the government to review every year this plan and also to update it and to see how it's progress towards reaching the climate goals. So as part of this, a couple of initiatives have come in place supporting the transition to circular economy, such as the whole of government circular economy strategy, which is the first circular economy strategy in Ireland and was published in December of 2021. Also, the Circular Economy Bill, which is a landmark legislation because it's the first time that circular economy is placed on a statutory footing. Also worth to mention that in terms of the circular economy strategy, there will be a second version coming on by the end of this year. Other important initiatives are the Circular Economy Program led by the EPA, and in the most recent ones that we have is the National Waste Management Plan for Circular Economy and the Green Public Procurement and Action Plan, which all of them highlight the importance of this transition to circularity. So multiple regulations that are part of that circular economy policy overview that I just gave you evidence that adopting circularity has become a need to have rather than a nice to have. I don't have time to go into detail to explain each of these regulations, but this slide summarizes a key takeaway on our report, which is that going clockwise, the ESPR is a driver for business to adopt circular designs and will include requirements for products placed in the EU market. Then the CSRD is a driver for reporting on circularity. And finally, the Digital Product Passport is an enabler of circularity, given that information flows which are required to keep goods and materials in use in the economy for longer. As I mentioned, I cannot go into detail right now, but you will find a better explanation of these regulations in the best practice guide, and also an analysis on why adopting circular economy practices is a future-proofing strategy for the evolving regulatory landscape. Now, moving to AI, these are some of the legal considerations business should take into account. So AI, as well as circular economy, are rapidly evolving in the regulatory landscape. So the European Union has just published on the 12th of July, the first ever comprehensive AI legal framework. And what it aims to do is to encourage the development of AI, but at the same time, balance it with the protection to individuals and society as a whole. This EU AI Act will enter into force on the 1st of August of 2024 and will be fully applicable in August 2026, but it will have a phased timeline. This means that some of the provisions will be applicable earlier on. It has a very broad scope. It applies to those that develop, provide, deploy, distribute, or use AI systems in the European Union, even if they are not located in the EU. And it will cover any product or system which can be classified as AI system. It uses a risk-based approach. This means that the higher the risk, the more strict the rules that you need to follow. And it has 4 categories of risk. The first one is unacceptable risk, that is related with the fundamental rights or EU values violations. An example of this is the use of social scoring by governments, the high risk, that is the AI systems that have a high potential to cause harm to society. An example of this is the recruitment tools that discriminate candidates. And then limited risk are the ones that have a minimal risk, but they still require transparency obligation just for users to be aware that they are dealing with AI systems. An example of this is the chatbots interacting with customers. And finally, the minimal risk are the ones that at the moment pose little to no risk, but they just leave it open to regulator later on, depending on the AI progress. An example of this is AI video games. So these are some insights that we developed in collaboration with Circ AA team of the Maynooth University. These are some things that we think business should consider if they're thinking of using AI for circular economy and to ensure their legal compliance. So the first thing is it's important to undertake an inventory and classification of any usage of AI system within your business. This in order to identify the risk categories of AI systems that are being used. We believe that they might likely fall on limited or minimal risk, but we need to see more examples and wait for the implementation. As you see, the act is very new. So we will need to see this to have a more clear understanding on the risk category that they will fall into. It's also important to understand the role you play, because depending on your role, your responsibilities change. We will suggest to maintain a detailed documentation about the data used to train the AI systems, and also the measures that you're implementing to secure that your system is safe and reliable. And then also to keep in mind other relevant regulations, such as the GDPR, because AI, for example, requires vast amounts of data for training. So business should be very careful with the use of citizens' personal information and data. Also in terms of intellectual property rights, because determining the rightful owner can be complex when AI is involved in the generation of content. Finally, in terms of ethical considerations, we explained them in more detail in our report, but I will just give as an example the first two. So fairness and bias refers to the fact that because AI systems are trained with vast amount of data, they might inherit cultural or social biases that could translate into unfair outcomes. So business should keep an eye on that. And also the importance of humans in the loop. This means that AI systems should be always operating under human supervision, and the employees of your companies should be trained in a way that they are able to assess and challenge the AI systems. So that's all from me. I will hand back to Geraldine now. Thank you.
Thank you, Valentina. So having kind of given that overview of the various elements to consider when thinking about utilizing AI for circular economy, I just wanted to highlight some of the insights that we've had going on this journey with Irish stakeholders on this topic. So one of the first things we did at the beginning of the project, before we did any stakeholder engagement, was do a review of different views of what key barriers and enablers of adopting AI were. And these can be flagged and categorized in terms of technical barriers like data availability, quality, integration, integrity, and interoperability. We've heard from Valentina around the challenges and the ethical and legal considerations around data ownership and privacy. And equally, we heard from Carlos with regards to things like thinking about the infrastructure and technology, and those who have good data management kind of practices already are likely to be able to capitalize on AI for a business goal like transitioning towards a circular economy business model. Equally, from an organizational perspective, this is reported in the literature, and it's something we've also found with our engagement with industry stakeholders, that a barrier to adoption is also understanding, like Carlos said, not about the hype of AI, but the different tools and what they can be used for. That knowledge is not something that is yet widespread from our engagements in, and what we've heard from Carlos with regards to the Eurostat figures in Irish industry. And connected to that is lack of skills, connected to leveraging AI or those data analytics data science skills, which are needed in order to deploy AI in the service of circular economy goals. Equally, from a policy perspective, things that have been cited in the literature internationally relate to the concerns about job displacement, safety, citizen awareness and trust. And these are all things that businesses do need to bear in mind as they embark on the journey to use this tool in an appropriate manner. We were reflecting back on some of the insights from the industry participants at our stakeholder engagement workshop back in March 2023 in collaboration with Circ AI. And of the industry participants, they were both public sector and industry. We asked industry members to identify the biggest challenges for their organization in using AI for circular economy. And you can see by this bar graph that fundamentally, while those organizational barriers that I just discussed were coming out on top, fundamentally the combination of both the technical and the organizational and the financial investment required if you are not already leveraging or collecting data in data management systems are in combined equally key to, I suppose, hindering the adoption of AI in the context of circular economy. Fast forwarding a year, and this is insights from the decision support tool and the user participant feedback reports. We've had 37 responses so far. They've predominantly been from senior management, and the majority of the participants have been working in manufacturing or technology in Ireland. And what they reported was that over half of them have basic knowledge of both circular economy and AI. However, a quarter are using AI in day-to-day operations. Equally, over 3/4 are exploring or in the process of trying to integrate AI into business operations. Again, while circular economy awareness might be low, given the manufacturing industrial base that we kind of engaged with back in April and through the Manufacturing and Supply Chain Expo, there is opportunities because manufacturers are familiar with Lean and Six Sigma, and there's a natural extension, going on a waste hunt in the context of value to linking towards circular economy. However, of the respondents into and users of the decision support tool thus far, over half reported that it was critical that there was an alignment between business goals and needs in order to adopt circular economy. Again, something that we've experienced in other circular economy initiatives that IMR leads, followed by regulation. So regulatory drivers are important because they give clear signals and keep things on, the agenda in kind of busy operational day-to-day realities. And then again, the kind of that sweet spot where ultimately that circular economy practice or business model can lead to carbon emission reductions. For example, in the built environment, we heard from Enya with regards to St. Bell, the food sector with Winnow, automotive, and then consumer goods. Those carbon emission sweet spots are really important to encourage companies to invest in both whatever technologies, because we heard again from the case studies and from Carlos how AI is often deployed with different technologies, be it drones, be it additive manufacturing, be it imaging systems, but all of those require R&D and investment. So to conclude, fundamentally, the resounding kind of takeaway from this process, both working in, looking at the work of and the findings from Circ AI and our own, is that AI and circular economy are at a very early stage of adoption and maturity level in Ireland. Awareness of circularity is still low. It is mainstreaming. We've tracked huge grounds over the last 5 years, but most manufacturing businesses in particular understand circular economy in that context of Lean and Six Sigma and expanding process efficiency. So the true potential with regards to business models is something that still needs to be mainstreamed. Equally, as Carlos flagged, Irish manufacturers are interested in AI. This was kind of validated by feedback from the stakeholders we engaged when we launched the tool and at the Manufacturing Expo, but AI adoption is still not widespread. Equally, we've concluded that Irish industry remain largely unaware of AI's potential for enabling circularity because awareness of both AI separately to circular economy and awareness of circular economy are still not yet fully mainstreamed. The other thing is that, again, we struggle to find Irish use cases that had publicly available impact data. So the examples that we've included in the decision support tool and our best practice policy and industry guide are largely international. That's not to say, however, that AI is not being used for circular economy goals or objective. It's just that we don't yet have the associated impact data. So we are aware of, for example, an associated IMR project, Circulera. We are aware of Circulera members who are exploring the use of AI. However, it may not yet have been piloted. So again, we don't yet have Irish use cases with publicly available data that really showcase the potential yet. So again, with regards to the role of AI as an enabler of circular economy, as Valentina highlighted, both of these separate topic areas have evolving policy and regulatory frameworks. So it remains to be seen the implications with regards to the crossover at the intersection of AI as an enabler for circular economy. But fundamentally, the key message is that the AI EU Act, its risk framework, is applicable to anyone considering implementing AI or utilizing AI for circular economy purposes. So AI can deliver business and circular economy goals, but some of the key barriers to implementing AI that we've, again, from both the literature and our engagement with stakeholders, highlight that these skills gaps with regards to understanding how to use AI. As Carlos said, AI, like any tool, needs to be used appropriately. There's capital investment required because AI is often coupled with other physical infrastructure or other technologies, as I mentioned in some of the case studies highlighted: drones, additive manufacturing, vision systems. Data access, data quality, data management is key, and then governance highlighted in order to ensure legal obligations and ethical considerations are taken care of is key. However, AI can help and overcome barriers to scaling circularity because it can enable process optimization. We've seen examples of how generative design can contribute to lightweighting of products, elimination of waste, and improved potential for recycling. And ultimately, big data can allow us, we saw in the Optoro case, the understanding of, predicting what the quality of a potential product is, not only in returns, but equally when considering repair, refurbishment, or remanufacturing. So to conclude, before handing back to Gary for some Q&A, ultimately, AI is a means to an end rather than an end in and of itself. So thank you very much. I will now hand back to Gary to facilitate the Q&A.
Thank you, Geraldine. Excellent insights there. And thanks to all our presenters. Carlos, as always, such a wealth of knowledge around AI. And as you said, AI is here to stay. And yeah, great to hear those real life case studies and to see the proof around the implementation. And Valentina, forgive me, the policy and legal framework may not be as exciting, but it's probably the most important part, highlighting that circularity is a need to have as opposed to a nice to have, and the importance of ensuring legal compliance with AI. Brilliant stuff from you all. And a big thank you to Leanne Conroy as well for managing this webinar and keeping everything running in the background. So we are all back in now, so we'll get to the questions and answers. And for all of you attending, if you have any other questions, you can use the Q&A function at the bottom of your screen. First up, the case study on General Motors highlighted the benefits of generative design AI. Are there any similar success stories from Irish manufacturing companies that you can share? Maybe Carlos, you can go for this.
Yes, I can take that because actually we have a use case similar to that one. This was, I think, 1.5 years ago with an engineering company in Ireland called Romon. And the objective was to build or create a new design for a component of an excavator, for the excavator hitch. And the goal was to come up with new designs to decrease the weight while still keeping the same structural strength. So as a result of the project, we came up with many different potential designs. I think 3 of them were the most promising, with up to a 40% decrease in weight over the traditional designs. So yes, as I said in my presentation, I think there's a lot of potential for generative AI in this particular regard, for creating new designs and looking at creating designs that also are good at a more circular life cycle.
Thank you, Carlos. And given the financial barriers are significant for many companies, are there any funding opportunities or incentives available to support AI-driven circular economy projects?
Sure, I can dive in, Gary. There are many different funding mechanisms both at a national level from the likes of Enterprise Ireland and IDA Ireland. There are digital vouchers, there are climate action vouchers, there's Green Start Plus, I always forget the portfolio of green vouchers, and also things like innovation partnership program mechanisms which can be leveraged by industry to explore this intersection of using AI for circular economy. Some of those grants are specifically for, there's a digital innovation voucher, some of them are specifically for climate action or circular economy or sustainability, but fundamentally those can be leveraged to explore this intersection. And again, Horizon Europe projects are also a mechanism, because this is a hot topic, because of the EU AI Act. And not to mention, and perhaps one of my colleagues could pop in the chat, IMR, an affiliated project called Factory Exchange, also has innovation vouchers. And Carlos, I know we were chatting before today, you mentioned how these are being used to explore AI. Perhaps you could elaborate a bit.
Yes, I can. Thank you, Geraldine. So yes, Factory Exchange Service is a very easy, simple way. I think it's like 20 minutes work for the companies to apply for it, to get into probably a feasibility or how to look at a particular application that AI can be used. Like, for example, we are working in several, like we have 3 active at the moment related to AI. One is more about computer vision, and the other 2 are using actually generative AI, which is a hot topic, and everyone is looking at how these large language models can help. So one of them is to look at maintenance in particular. Many times there are so many maintenance manuals, so many technical documentation, and it's very difficult to find the correct information for a particular problem. So how can an LLM work about that? It's, I think, a very good use case for large language models, or even looking at programming CNC and 3D printing machines. How can large language models help with that? So yeah, Factory Exchange is a very good, easy service for companies to start doing applications in AI.
Great, thanks, Geraldine, and thanks, Carlos. Next question. Are there any training programs or resources available for companies to build internal capabilities and skills for implementing AI in circular economy initiatives?
Yeah, I think again, because the 2 topics are still emerging, and there is that intersection point that, you can look at AI separately from circular economy. A lot of the training and capabilities and capacity building supports perhaps are separate, but to give an example of where these have come together in the context of IMR, in an affiliated program called Circulera, the National Platform for Circular Manufacturing and Innovation, we last year looked more broadly at digitalization and its role as an enabler for circular economy with our members. And that had an element of looking at the regulatory drivers for innovation and the fact that companies need to think about being future fit and how to leverage these advanced technologies. And I'm sure Carlos can highlight more specifically some of the training that IMR has developed in the context of AI specifically.
Yes, sure. For example, myself, I give a course on introduction to AI and machine learning, where I try to, again, demystify AI, look at everything around the term artificial intelligence that I mentioned, many different technologies, right? Not just machine learning, and in particular to manufacturing. So this is for manufacturers to understand what AI is and machine learning and how it can be used. It's not very technical, it's an introductory course, but I think it's useful if you want to know a little bit more about AI. And related to this also, we have an initiative internally in IMR where we are looking to how to use AI to improve the training and the education of people in manufacturing. I think that's a very interesting topic right now, and we are looking into that as well.
Thank you both again. Next question in from Chris. He said, I'm particularly interested in the collection and segregation part of the CE product life cycle in Carlos's presentation. Is AI a suitable tool to monitor the cumulative efforts of social enterprises in this work? And is AI suitable in a widely distributed system involving dozens, even hundreds of small actors?
I'll try to answer. I'm not very clear on exactly the question, because to monitor cumulative efforts of social enterprises. So let me know in the Q&A if I am correct in answering your question. If not, I'm happy to get back to this one. So what I see there is AI suitable in a widely distributed system involving thousands, hundreds of small actors. Well, from the point of view of getting many hundreds or thousands of different, let's say, data generators, because in this case, every one of those actors will be creating some data. Yes, AI is where you need to look at to get information from many different sources and making sense of it and actually getting the insights, the patterns that it finds. So without knowing more about the particular interest, I would say in principle, yes.
And Carlos, I might be able to shine a little bit of light just because
Sure.
I know we didn't actually highlight an example of the use of AI in the context of waste management. There are examples both internationally, and we're aware of them from members of the Circular Network, but again, there's no publicly available data of the impact of the Irish ones, and that's why they're not explicitly included in our, I suppose, our analysis. But fundamentally, the use of robotics and vision systems in trying to reduce some of the hazardous elements of waste collection and segregation is something that is, I think the waste management sector is probably pioneering because of the negative impacts on humans or the risks with processing certain materials. But fundamentally, I think, and Chris has come back to say that you have addressed the question. Ultimately, data is key. So if you've got lots of different social enterprises, it depends whether they're going to collect data, how they collect the data. But fundamentally, the potential is more about the data than anything else. And as you said at the beginning, companies or actors or organizations who've got good data collection, processing management are more likely to be able to leverage AI, and then anyone can use it, if that's fair to say.
Great, thank you again. Next one is in here from Bernie. How can national and EU circular economy policy best support the adoption of AI for circular economy objectives?
So that is a very good question, and one of the things we've been grappling with is fundamentally, where is that intersection point, given that the two are kind of evolving in parallel. One of the high-level takeaways is that the National AI for Good strategy does not explicitly mention the role of AI as an enabler for circular economy. And I, without wanting to speak on behalf of the NUTH, the conclusion that both these two projects, AI4C and Circ AI, would have is that AI has a role to play, even if it's not yet proven in Ireland. Internationally, it is being used along with a range of digitalization and advanced technologies. So I think the intersection where industrial policy, AI policy acknowledges this is really important to give signals to industry to raise that awareness that we flagged about the fact that there's limited awareness of AI or adoption of AI. There's limited awareness of circular economy, never mind the role of AI for circular economy. So I think public sector actors have a role to play in making those connections in industrial policy, in AI policy, with circular economy more specifically, and equally, similarly to other elements of circular economy, the public sector perhaps has a role to play in being a role model, perhaps in deploying AI and then sharing the outcomes and impacts in terms of how they are adopting advanced technologies to reduce and eliminate waste, be it in, for example, the public sector's building stock or other ways that we've seen here today. I hope that has addressed the question.
I'm sure it did, Geraldine. Another question here from Frank. For widespread adoption of CE, does the panel think this will be driven more by government regulations or by business need for financial and process efficiency and transformation?
Valentina, would you like to have a go, and I'll row in behind you?
Sure. Thank you. I think it's a mix of both, to be honest. I think there's some regulations that do drive and make it happen maybe quicker because there's deadlines, there are timelines, but there's also needs to be a business drive. So I think we need like both of them to get to the results we want, especially because of the very tight deadlines we have on climate targets.
Yeah, I would concur that it's there's never it's never an either or, it's always yes and both. Fundamentally, what the government regulations, the policy environment does is, because circular economy is on statutory footing, it sends a signal that this is not going away. So regardless of the hue of government that may be elected in the future, fundamentally, in order to be future fit, in order to be able to operate both in the European market at an EU level, embracing circular economy is fundamentally non-negotiable. You may not have to embrace it today, but in the next 5-10 years, it's going to be a factor of doing business. It's going to be a factor of placing products on the market in Europe, and Ireland is in Europe. So, depending on where you're exporting to, and the European Union is using this to drive this broader adoption. But as we've seen, as Valentina, Carlos, and you have shared, ultimately, industry coming to capture competitive advantage means it does need to deliver on business goals, and it does need to deliver on cost savings and emission reduction. So there is a sweet spot where industry will take a front runner approach, but fundamentally the regulatory environment creates that framework to keep this on the agenda if that sweet spot does not yet exist in your sector or in your supply chain or business.
Great, thank you, Valentina and Geraldine. And last up here, the General Motors case study that Enya went through, it talked about, developing a product that's using less material and it's going to be stronger. What are the downsides? And the second part of it, how as a manufacturing company do you identify where this can work in your manufacturing company? Or where do you start?
Okay, I will answer that. So when you use generative AI for this, basically you get many potential designs, right? Selecting one can be difficult because all the constraints of actually producing and using them. So when you do generative AI, you try to input all the constraints you can about how you are going to actually use the product. But we know from experience that once you get a design and you use it, and you find more constraints, and I didn't think that this could be a problem or whatever. So it takes time and some iterations. So it's not, again, it's not a magical wand to fix something. It can help, but sometimes it doesn't work, or you find that what looked good on paper, on the design, then the reality is more difficult. So it's iterative. So for some companies, maybe they don't have the resources to actually go into this iterative cycle for a long time. But probably that's the downside, the biggest downside you need to be aware of. As many times with AI, you need to be aware of what AI is selling in this is going to solve my problems easily. And then the actual use of it, as I said in my presentation, you need to be used to work with data, to work with AI, and figure out how is the best use for your particular business challenge.
Brilliant. Thank you, Carlos. And we are just about out of time. So thank you all for joining. Thanks again to all of our presenters today and for everyone involved in the AI for CE project. We do have another webinar coming up on Thursday week, and it's on understanding PFAS in water, essential knowledge for manufacturing. I'm just going to drop the link in there for anyone that's interested. This webinar was recorded. We will send all of you who attended and registered the recording with all the links that we mentioned throughout the webinar, so you can rewatch it or you can share it with a colleague. So everyone, have a great weekend, and thanks again for joining.